Welcome to JACC Imaging. I'm Morton Kern with the University of California, Irvine and Long Beach Veterans Administration Hospital in Long Beach, and I'm here today with Gary Tearney, Associate Professor of Pathology at Harvard Medical School and one of the founders, developers, and innovators of optical coherence tomography. Gary, welcome.
Thank you.
We're going to talk today about optical coherence tomography as it has evolved and come into the use in clinical practice. Can you tell us, just briefly, in the last 2 years since we last spoke about this, what's our newest advance and application for OCT?
All right, so about two to 3 years ago, the major advance in OCT was the development of the second generation form of coronary OCT. It goes by two names. One is called frequency domain OCT, or FDOCT, and some people call it optical frequency domain imaging, or OFDI. They both mean the same thing. The big advance of these technologies is that it allows imaging of coronary arteries very rapidly. For instance, you can image 5 to 10 centimeter segment of coronary artery in roughly 5 seconds. And you do this following a non-occlusive radiocontrast or saline purge and rapid helical pullback of the catheter. And the reason why this advance was so important is because it overcame the blood limitation of the previous generation version of OCT, making it practical to do OCT in the cath lab.
Right.
At that time, when we last had this interview, we had just published the first in human demonstration of this new second generation form of intracoronary OCT. And what has happened since is that this has really taken on. And multiple companies are now producing products. Light Lab has a device approved for human use in the United States as well as around the world. And there's a tremendous amount of excitement and exponential growth in the OCT community. And you can just see it at the conference, the pulse around OCT imaging and the promise that it may have for interventional cardiology in the future.
Right. These images that OCT produces are particularly striking and easy to interpret relatively. However, some interventionalists are still comparing Ivis to OCT. Can you tell us the biggest difference that the operator is going to appreciate between these two and why there are such differences?
So in terms of the images, the major differences between OCT and Ivis are: one, OCT has 10 times better resolution than Ivis. So you see a lot more detail of the artery wall. And that's really critical because many of the features that you're looking for instance, stent microstructure or plaque microstructure, are more easily appreciated by OCT. It's also advantageous because you have all this additional information. You can better characterize what's going on inside the wall. The downside to OCT, if you will, is that it doesn't penetrate as deep as Ivis, especially through some types of plaques, like lipid-containing plaques. And as a result, with OCT, you don't see the back edge of those plaques, whereas with Ivis, you very well might. So OCT is great for the superficial microstructure, but sometimes it doesn't see the back edge. And sometimes to get a full picture, you need both OCT and Ivis. OCT for the detailed structure and Ivis for the size or the plaque burden or the thickness of a plaque.
Great. Now, I'm an Ivis user, and I measure the lumen to be some number, 3.8. And now I put in OCT, but my measurement is different. Should I be surprised at that?
You shouldn't be surprised at that. The measurements should be within 20% of one another or something. But in order to understand why measurements might be different between OCT and Ivis, you have to understand a couple of principles. One is, compared to Ivis, OCT imaging of the artery wall now is very fast. So it takes, let's say, a few seconds to do a full pullback of an artery, whereas with Ivis it may take a few minutes. What this means is that in OCT, you may be imaging through 1 or 2 cardiac cycles. The entire pullback occurs over 2 cardiac cycles.
Right.
With Ivis, it may be hundreds of them. So you may be making your measurement at a completely different phase of the cardiac cycle than that Ivis image that you're comparing it to. And as a result, the artery may be 10 or 20% different in luminal diameter, or it may be right on the mark, it may be above, it may be below. But if you haven't synchronized the EKG cycle to your OCT image and to your Ivis and make sure that you're looking at the same point in the EKG cycle, then you really can't compare those measurements precisely.
This is a really important piece of information for our viewers to appreciate in the use of Ivis, and I think it's not widely known that this is actually the case. And as we get more experience, hopefully this will really help us. Now I wanted to ask you, what do you think are the major clinical indications for Ivis? For OCT. Yeah, for
OCT, I think that today what we see is that we're able to look at the microstructure and potentially the composition through the microstructure of the artery wall with really incredible detail. And the advantage to this is it allows us to sort of see, or allows interventionalists to see what they're doing before they do it. And right now, interventionalists use the angiogram, which is essentially a shadowgram of the lumen. Mm-hmm. And oftentimes that's not representative of what's happening in the artery wall. With OCT now, you can look at what's going on in the artery wall, you can think about that, you can take all of the knowledge that you know and then use that in trying to determine the most appropriate management strategy.
Great. We have just a moment left. What would you like to tell us about the formulation of the uses for this tool as we all start to incorporate this into our laboratory?
So I think one of the things is to look at what we're doing today in terms of standardization. I'm very happy to say that the OCT community has really banded together and formed a major working group called the International Working Group for OCT Standardization and Validation. This community is really growing, it's thriving, and is working very hard to develop a consensus on how to utilize OCT, to determine how to interpret the images that are obtained, and also the pitfalls and the artifacts and the unknowns. And we're putting that down in a piece of paper in a consensus document, and it's just a really exciting time to see the community come together and really try and develop a document that will increase the utilization of this technology worldwide.
Well, this is a fantastic advance in interventional cardiology. I'm looking very much forward to using the OCT in our lab, and I want to thank you for sharing that information with us today.
Great, my pleasure.